All right, problem number 19 in group theory. A characteristic subgroup of G is a subgroup H such that phi of H is equal to H for every automorphism phi of G. For part A, suppose K is a characteristic subgroup of H and H is a normal subgroup of G. Prove that K is a normal subgroup of G. Okay, so I'm going to restate the assumptions. Suppose K is a characteristic subgroup of H, and H is a normal subgroup of G. Since H is a normal subgroup of G, we can define an automorphism of H by conjugation with G. So we have phi sub G going from H to H, text defined by phi sub G of H equaling G inverse. So let's read this. Since H is a normal subgroup of G, we can define an automorphism of H by conjugation with G. That looks like this. Okay. Since K is a characteristic subgroup of H, we have that phi sub G of K is equal to K, and by the map above, we have that phi sub G of K is equal to GK, G inverse, hence K is equal to GK, G inverse for all G in G. This is the definition of being normal in G. Therefore, K is a normal subgroup of G. Which concludes part A. Part B says, show by example that the conclusion of A is false if we only assume K is a normal subgroup of H. Okay, begin proof. So we're gonna let G be S4, and H, a normal subgroup of S4, is the Klein 4 group, and H be the Klein 4 group, which we'll explicitly say what that is. It's the identity 1, 2, 3, 4, 1, 3, 2, 4, and 1, 4, 2, 3. Okay. Klein 4 group, this is a normal subgroup. Sorry, since we only assume K is a normal subgroup of H. Okay, so we want a K to be since K4 is abelian, any subgroup of, maybe I'll say H here. Since H is abelian, any subgroup of H will be normal. Hence, let K be, we want the subgroup with the identity and just 1, 2, 3, 4. Okay. So observe that K is a normal subgroup of H. However, K is not a normal subgroup of S4. Since, we'll show why, if we take the element 1, or the cycle 1, 2, 3, and we multiply this by 1, 2, 3, 4, and we're conjugating because we're testing normal. If we were to multiply this out, we would get 1, 4, 2, 3, which is not in, sorry, it's not in K. Hence it's not normal, which is not in K. Hence K is not a normal subgroup of S4. And I guess I'll label this B, and that concludes problem number 19.